Welcome to EDU World Space.
All right, so we have the following molecule. And we need to determine the likely splitting tree for the circled hydrogen. Okay, and so what I would first do is count how many neighbors we have and what the magnitude of the splitting constants will be related to those neighbors. So first up, I notice we have the so-called geminal case, right? Geminal coupling on an alkene, right? And this usually is about 0 to 3 hertz. So it's a very small splitting constant. Okay. And then we have the vicinal cis. Oh, by the way, geminal means on the same carbon. Vicinal means on a neighboring carbon. Cis is referring to the relationship of the hydrogens across the double bond. A vicinal cis splitting constant is between like 6 and 14 hertz. Okay. So we notice that the splitting for the vicinal cis hydrogen, let's call this B, and let's call this hydrogen A, right? A is our geminal, and B is our vicinal cis. The splitting constant for B is much larger than A. Okay, so we expect then that our signal will get split by B somewhat largely. Okay, and then A will split each of these new signals again. However, notice that it's going to be like much smaller or significantly smaller than the splitting from B. It's going to be less than half. It's it might even be 1 hertz while this is 10. So it's going to be significantly smaller, right? Something like this. Okay, and that's how I would build up the splitting pattern for this particular case, right? One very large splitting from B, and then one very small splitting from A, which you'll notice corresponds to option 3.